So in this video, we'll be going over on creating the hardware for the elevator, and we will have different inputs that relay on buttons, and then the outputs relay on LEDs that specify what's occurring with the functionality of the elevator. All right. So the three different inputs is the alert button, and then the two inputs that the user would be inputting um, that designate which floor that they want, right? And it's good to keep in mind as well that we're starting from the first floor, right? So they will be advancing from any of the other three floors up to the fourth floor, right? So we start at 0, 0, and then 0, 1, 1, 0, and then 1, 1, right? 1, 1 being the fourth floor, right? And then here's the alert button, and then if alert is high, so we have an input signal, then we'll send an emergency, and whatever floor, current state floor you're in, it's going to drop to the first floor, right? So that would be resulting in the floor LED resultant to be 0, 0. So both LEDs are going to be off, which we'll cover soon. And so for our outputs here, I'm trying to be clear as possible. This direction is going to be a blue LED, and this one is going to be telling if we're going up or down, right? And it's going to keep in mind on that throughout its duration. And elevator position has two key roles, right? So it's going to say if the elevator is open or if it's closed, and then also it'll tell us if it's moving, right? If it's moving, then it's gonna just flicker, right? It's gonna flicker consistently, and that flickering is gonna have a higher frequency when it's starting, and then it's gonna slow down in frequency as it's approaching its stopping point, right? And of course, it's assumed, right, that as it's moving and then as it comes to that sudden stop, right, the the elevator door is still going to remain to be closed, right? And so this will be signifying it when it's moving, and then when it's the door is going to be opening or closing, okay? And we'll be seeing how that's being operated. And then these two LEDs are to signify in binary, right? Which state we are in, so which specific floor we are in, right? And of course, we're going from the first to the fourth floor, and that's what's going to be depending on. Okay. Here, we're just initializing that we start from the ground floor, right, which is going to be the first floor, right? Okay, and then and here is taking this function read floors is taking control of the user's inputs, right? So first we check if the user has sent an alert signal, right, from the alert button, right? And then if so, then we'll be returning 0, 0 for the initial inputs that the user can choose, right? But it will be true, it'll be 1, a high signal for the alert value, okay? Um, and then and then here, if depending on whatever value is being read for MSB and LSB for the flow request inputs, the button inputs, then they will be sent accordingly to MSB and LSB to record which state we're going to be in, right? And then according to those specific inputs, we want to translate it to where it can be specified on what state we're in, right? So, of course, here 0, 0 signifies to the first state, so state 0 we can call it, and then we have state 1 for the second floor, and then state 2 for the third floor, and then state 3 for the fourth floor. Okay, and these also, you can say that these also signify uh, the pattern of the LEDs, right? Because on the specific state that we're in, the current state that it's in, it's um, it's going to signify that on the LEDs that we're going to be seeing soon here. All right. And then of course this return -1 is just a precaution to make sure that we don't get any faulty inputs. Um, so this is a separate function that's on designated when it's designated to move, right? We want to keep track of the current state and next state, right? And so we want to manage essentially mainly the frequency that of which it's moving, right? Because logically, how I thought of it was um, it's going to have a longer duration, right? As it's going from like the first to the fourth floor, right? That frequency is going to be spread longer than if we were going from first to second floor, right? So we want to have of course a longer length, and then that length is then going to be stretched more while the frequency cuts down slower than compared from like from first to second, than rather first to fourth, right? So we take that difference to signify the floor difference, right? And then we essentially do like a new counter, right? That will uh, resemble that higher value that we're going to be counting down from, right? And then 60 hertz is the max frequency our eyes can really see. But just to be on the safe side, so that the user can actually see the light, we put the max frequency at 40 hertz. So that's going to be the max frequency that you're going to be seeing, and then of course from there it's going to be slowing down, right? Um, so before there's any flickering, right? Uh, anytime an elevator is functioning, it's going to have to open first, right? And then after some time, it's going to have to close, right? So we make sure that the elevator is closed before it's moving, right? So that's why we make sure that the elevator is at its closed position, right? And then we pause. And then, um, and of course, this is or just like our scale factor for the flickering, right? And then here we're just counting down, and we don't want it to be forever because it could be -1 consecutively for each time this while loop occurs. But I just noticed it took too long, so I just did -5 for each duration as it's in this while loop here. And then for this frequency here, of course, we want a percentage of that frequency that we want to cut in half as time goes on, right? Or deduct from counter new, right? So um, then we just want to grab that ratio and of course cut it down as the while loop goes on, right? And that's the thinking process to um, as time goes on, subtly change that frequency and make it not so apparent. And so, and then of course we cut get half of the period so that we can have half of the period when it's on and then half the period when it's off, right? So that's the flickering for the LED. And then setting the direction here, we want to make it's very simple as if the next state is greater than the current state, then we know that it's going up. And then if it's not, then we know that we're going down, right? That's how that's going to be. And then for the transitioning of states, this one's important because we want to make sure that our next state that we're going to, so like let's say we're going from the first to the third floor, right? We want to make sure that that next state is going to be our current state, so that new state is going to be kept, right? Um, so uh, when we do that, we also want to make sure again that the elevator remains to be closed, right? Before it's clarified that we're moving on, we're going to make that next state to our current state, right? So we signify, of course, that it's closed, and then we update and say the next state is going to be equal to our current state, and then that's when the elevator is going to open, right? And then that's when we're going to be returning our current state here. And then this update floor LEDs, it's just using the modulus and the floor division to result in either 1 or 0, right? And this is a simple form of doing that. And then elevator main, we're just putting everything all together here. All right. We claim our current state. We set our counter to 100. That worked fine. And then we want to make sure that our elevator starts at 0, right? And then if there's any sort of input that the user puts in, then that's when we're gonna call in our following functions, right? But if there's nothing, then that would mean that the elevator just stays closed, right? The elevator is just going to stay closed until the user requests for it, right? So then, when the user gets a received input, right, then we're going to open the door, and then we're going to be reading the input, right? And then if we get an alert, the alert button, then we want to move and transition to the first state. So we want to go to the first floor immediately, okay? But if not, we don't get any sort of alert, then we're going to be wanting to transition to our next state, okay? Um, and and um, well, this variable next state, it's equal to the next state because this is the room that we want to go to, right? Um, so that's why next state is equal to translate floor, which of course is getting our specific state from the user's input, right? Um, and then so from here the door is open, and then of course once the user puts in their floor number, then we're going to close it, right? And then we signify which direction they're actually going, and then we have this flicker LED, which then launches them. It closes back the door. We make sure that we close back the door, and then we launch and go off to whichever floor they want to go to. And then that is when they're at their specific floor, and we make sure that once they've reached their safe spot, right, then that next state then becomes our current state, and that is going to be a state that's going to be held until there's a next another input, right? And then over here, we want to then update the floor LEDs and make sure uh, that the user knows which floor they're in. That's going to be signified by the two LEDs. They're going to be two green LEDs. And then, of course, this is just going to be the looping in its entirety in um, the while loop here. Okay, so now I'm going to be showing the implementation. So setting everything up here, it is good to note off that whatever was shown in the beginning with the GPIO pins, that all correlated from the Kira GPIO pins to that of the breadboard, so all that was accurate. But anyways, so this pin was for the alert, and then these two pins were the input pins that the user would put in, right? And then of course these on one end from these buttons is high, right? And then we have the input signal and then resistor to ground, right? So um, this works so that when there's a true signal, or right, whenever there's a high signal, we would have to press down the button here, right? And then this right here, this was recorded at like a current state, right? So, but in here we would see that we're in the second floor, right? Because we're in the second state, um, or we could say first state actually. Sorry, because we're starting from state 0, right? So this is state 1, right? Which is the second floor, right? Um, so this being in the second floor, then we would also notice that the door is closed here. But we'll be going over the little demo how that's actually operating, how that's operating properly in this elevator here. But anyways, this is the positioning of the elevator here, and then this LED is for if it's going up or down. Okay. Um, okay. And in here, we're going to be sending an input signal here. And when we send our input signal, the door is going to open, and then it then flashes, right? It's then flashing. It's flashing, and we're moving up. The door is going to then open, and then we are then going to the second floor there, as we can see. And we went from the LEDs going from 0, 0 to then 0, 1, right? Of course, this being MSB and this is LFC, right? So this is 0, 1, so this is the state 1, which is the second floor, right? And we went up, and if we were to notice here, we were to notice that it was flickering. It opened the door, so it had like the on position for a long duration, meaning that it was open to let all the people out, and then it closed, right? And then that is when we signified that the door, which floor they were in, right? And then if we were to press the emergency button, what happens? The door opens. Then we're launched to the first floor, and that LED, that blue LED that tells us if we're going up or down, turns off, meaning that since it's low, we are going down to the first floor, right? The door opens. You saw that long pause. The door was open for the people, and it's then signified that we were in the first floor, right? If we would then wanted to go to the third floor, right? We're gonna go up. It's going up. We arrived, and now the door opens, and then yep, we're in our state 3, being the third floor, right? Um, so yeah, so now we can see that this works actually quite well. Everything seems to work perfectly fine, and this actually works like a perfect elevator, where we're able to go from one floor to the next floor, and if needed, we can press the emergency button, and everything is good. And another thing that we wanted to notice is that we keep our state up until um, we transition by moving floors, right? So that is our elevator demo.